Alright, so we've talked about scripts, how to add scripts to the anonymous cheat table. What you could do if you wanted to save it, which you once you've added a script and you're satisfied with what you have here, you can go up to File and basically save. And Cheat Engine will basically say, what do you want to save it as? And let's just call it, say, nonsense. Done. Let's close it. See if we can make the point. Nonsense. You can see an Empire Strikes Back table here. It's something I worked on some months ago. Empty the recycle bin. I kind of use that just to sort of refresh my brain about the style and some of the sectioning that I used in scripts. But bring this up. Double click on nonsense. It's asking me UAC. Yep. Alright. Admin. Alright. So we're back up. There's no process per se, but again, you can double click on this, see it all still exists. Obviously, you can't enable it because there is no script, or there is no process to attach that it is attached to. So let's open up Shadowrun. Let's go to New Game, Launch Campaign. I think we will find rather quickly that we're going to have to make some modifications. Alright, so use karma, get rid of karma, use karma, yep. You can see it's going up, it's going down. Let's see what we get. That's not what I want. That's what I want. Let's enable the script, see what it does. If it even enables. Doesn't seem to. So whenever you try to go to enable a script and you're sort of sketchy about it, Cheat Engine will lock up. Well, there's no process selected, so of course it's not going to enable it. But yes, if you've written a script, that's basically back up here. If you've written a script and you've saved it to a cheat table, and then you reopen Cheat Engine and you attach it to another to a process, it's going to ask you, do you want to keep the code list? You obviously do. Otherwise, if you click no, you're going to Cheat Engine will basically forget everything down here. So we have clicked yes. Let's see if we can enable the script now. We hit that. Nothing seems to be happening. Let's try it again. Nothing. Alright, so what I like to do is, if I'm unsure or have some sort of question about the stability of my scripts, is when I go to click active, sort of, I don't immediately, run over and double click this, but I will sort of meander my mouse over and double click on the description, because Cheat Engine will lock up, especially when you use AOB scam. So you click that, maybe you double click that, alright, it's pretty responsive. So Cheat Engine is basically telling you, I have no idea what you're talking about. This address basically does not exist. Now, how can we prove that? Well, what did we do to create this script? What we did was, in order to actually find this memory location, what we did was we found the value for karma during character creation, and then we found out what wrote to that address, and then we showed dissembler code, and then we sort of did an did a code injection onto that location, and we sort of just Cheat Engine produced that address for us. So let's do that again. One more. One of them is going to be 100. There you go. Again, for the purposes of illustration, I don't care about the other value right now. So what are we going to do from here? We're going to find out what writes to this address. Yep. It's not populated because there's no events. Let's make an event. There you go. There's an event. We have one. pretty much on the right track. So, what is the address for this instruction? It is 158.7F121. That is clearly not anywhere near 1932 EC39. What the hell's going on? What the hell that is going on is that, just like variables or values, if you want to be somewhat more specific about it, is that cheat engine is, or not cheat engine, but the game is reallocating memory based on what it needs, and the absolute sort of addresses are changing. So can we come up with some way to make this script dynamic? Otherwise, every time we want to sort of use the script, we have to find the value, find what writes to it, and then we have to sort of cut and paste that address into this. Is there some way that we can make this dynamic? As a matter of fact, there is. It is called AOB scan, and if you have not heard of it, you will more than likely be familiar with it by the end of this video. AOB scan is it's a very, very awesome feature. It's not anything that is specific to Cheat Engine, but just the concept of it is good. It's awesome. It helps you out a lot. So let's click OK. The script's fine. We can sort of delete this. We're going to walk through this just one more time, I think. Alright, so what is the value that we want to find? It is 89 at this point. Let me think about this real quick. Do the 89 for the original value, or for the karma value. We won't have it for the player value. Doesn't matter for AOB. It does not. As long as we get first. Alright. So what is our available karma right now? It is 89. We get 1. Some value. Let's change it by some decent margin. We get 44. Alright. Find out what writes. Now, why are we finding out what writes? Because we want to know the memory location of the instruction that actually changes this address. Hit 1, hit 2, hit 3, out of karma. There you go. So we have an address, 15871 or F121. We're going to go to show dissembler. We're going to check Cam Studio. Do we have the time? We do. Alright. How do we use AOB scan to our advantage? The way that we do it, or the way that it is generally done, there's a couple different ways, but the basic way is that what you do is you scan for the bytes as listed in the memory viewer for the instruction that you are interested in over here on the left. So, what does that even mean? Well, we're going to go back to Cheat Engine. We're going to go to New Scan, Scan Type, Exact Value, Value Type, Array of Bytes. I don't care about, whatever's in there, whatever you have in there is going to be translated. I don't care about that. So what you want to do is you want to sort of find, or not even what you want to sort of do. What you want to do is you want to find the array of bytes as equal over here on the left to the bytes for the instruction. As we talked about, every byte has, or every instruction has a certain amount of bytes associated with it, depending on the complexity, or just sort of the just depending on the instruction. Every instruction has a certain amount of bytes associated with it. So this particular instruction happens to have 6 bytes because we've been messing with it for a while, so I just know that off the top of my head. So we right click on it. You can go to copy to clipboard. Want to copy bytes only, no address, just bytes. Let's do that. What we got? What we have is an array of bytes. You find that when you copy that, what we just clicked, it corresponds perfectly up here to what you have down here in bytes. That's not a coincidence. So what we have right now is we're basically, let's stop for a second. what does this even mean? What it means is that on a very, 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 very even lower level than we are talking about or dealing with right now with assembly, what it means is that these instructions, move, ESI plus E0, EAX, these instructions are essentially bit patterns according to the processor, and they have, as they are bit patterns, you can break them down into 4, 8, 12, 16, 32, 64, whatever you want. You can break them down into byte patterns according to, or into bit patterns according to chunks. And as it turns out, it's convenient to sort of break them down as byte patterns in, sort of 8-bit blocks. And when you do that, what you get is a byte array. Now, what is an array? It's essentially a series of values. We'll go to Wikipedia. We will ask it, what is an array data structure? This is sort of getting way out into left field. I don't want to spend too much time on it, but in computer science, an array data structure, or simply an array, is a data structure consisting of a collection of elements, values, or variables, each identified by at least one array index or key. I don't really want to worry about that. An array is stored so that the position of each element can be computed from its index tuple by a mathematical formula. Again, I don't want to worry about that. For example, an array of 10 integer variables with indices 0 through 9 may be stored as 10 words at memory addresses. Come on, give me a more general thing. There's matrix, matrices. All right, so basically, I can't believe an array is a series or a list, if you will, of values. It's really hard to explain this concept unless you sort of jump into it. But basically, I mean, you have an array. So, what is the array? It's a list of objects. What are the objects that you're listing? Well, they're bytes. So, I mean, if you convert the array to hexadecimal in the format of bytes, what you have is you have 89. Bring up a calculator here real quick. You have 89 in hex. What's that in decimal? You have 137. So, the first, unclicked hex, click hex. The first byte of this array is 137 in decimal. Whatever that means. It may not mean anything. And then what do you have from here? Well, the second byte is 86. Is that right? My contacts are killing me. 86. Yep. Well, but it's in decimal, so go back to hex, 86, decimal, 134. Go to E0. There's some crazy, I don't even want to call it crazy, but there's some value, 224. Basically, the hexadecimal to decimal conversion is totally irrelevant in this case. I was just simply doing that as sort of a demonstration, but basically, like, every single assembly instruction value over here corresponds to some bit pattern as interpreted by the processor, and as it is a bit pattern, it immediately translates to a byte pattern. And the byte pattern is what Cheat Engine is searching for when you say array of bytes. It is saying, give me a series of bits, and I will break it out into sort of 8-bit sections, and I will search for that list of 8 bits. Whether it's, the first 8 bits, or the second 8 bits, or the third 8 bits, or whatever. Just give me a stream, a huge chunk of bits, and I will break it out into 8-bit sections. I will convert those 8 bits, or each of those 8 bits, into bytes, and then I will search for bytes, or a byte array, or a series of bytes based on that bit pattern. So it sort of bubbles up, if you will, and once I click stop, we'll maybe bring this home a little bit and try and make this a little more concrete.